In this video, I'm going to show you how to solve difficult integrals which require applying integration by parts twice. For the first round of integration by parts, we're going to differentiate this x squared plus 3 term. So we'll set that equal to u. U equals x squared plus 3, so u prime equals 2x. And then v prime will be this cos x over 4 part. Then v is the antiderivative, which is 4 sine of x over 4. And we can use our integration by parts formula to express the integral in terms of u and v. So first we've got u x squared plus 3 times v, which is 4 sine of x over 4, and then minus the integral of v again, 4 sine of x over 4 times u prime, which is 2x. Now we'll multiply through and simplify a little bit. So here we've got 4x squared plus 12 times sine of x over 4, then minus the integral of 8x sine x over 4. Now this integral is still pretty tricky to solve, but we can solve it through integration by parts. So we're going to take this integral, we'll put it up here, and we'll do another round of integration by parts. We'll get this 8x term down to 8 by differentiating. So we'll set u equals 8x and then have u prime equals 8. And then we'll set v prime to be sine of x over 4. So that way v is negative 4 cosine of x over 4. And then using our integration by parts formula, this integral is equivalent to u, which is 8x, times v, negative 4 cosine of x over 4, then minus the integral of v again, times u prime. And now we can simplify this a little bit. So this is negative 32x cosine x over 4, then plus integral of 32 cos x over 4 dx. So that's negative 32x cos x over 4 plus 128 sine x over 4 plus our constant of integration. Now we'll take all of this and put it in for this integral here. So we'll rewrite this but substitute it in. 4x squared plus 12 sine x over 4 minus what we found for the integral over here. Negative 32x cosine x over 4 plus 128 sine x over 4 plus c. And now we'll just distribute that negative sign. So 4x squared plus 12 sine x over 4, then plus 32x cos x over 4, then minus 128 sine x over 4, and then minus c, but c is just any constant, so we can just keep it as plus c to represent any constant. Okay, and then just to simplify a little bit more, we can combine this minus 128 sign with this 12 sign and get 4x squared minus 116 sine x over 4 plus 32x cosine x over 4 plus c. And there we have it, we're done. This is the value of our original integral. Here's another example where we have to apply integration by parts twice. So we're going to start off by setting that ln x squared term to u, because that'll reduce down to a single power of ln x. When we differentiate, we get u prime equals 2 ln x over x. And then in the next round of integration by parts, we can reduce that ln x down to a 1 over x term and totally get rid of it. But for now, we've got to complete this first integration by parts. So v prime will be our 2x plus 1, which means that v is x squared plus x, and then this integral becomes u, which is ln x squared, times v, which is x squared plus x, minus the integral of v, which is x squared plus x, times u prime, which is 2 ln x over x dx. And we'll simplify this a bit. So this is just x squared plus x ln x squared minus the integral of 2x plus 2 ln x dx. And now this integral is something that we need to apply integration by parts again to solve. So we'll move it up over here, 2x plus 2 ln x dx. And then we will set u to be that ln x, which means that u prime equals 1 over x, totally gets rid of that natural log, and then v prime will be that 2x plus 2, which means that v equals x squared plus 2x. All right, so now we are good to use integration by parts formula. So u, that's ln x times v, which is x squared plus 2x, and then minus the integral of v, which is x squared plus 2x, times u prime, which is 1 over x dx. And since we've gotten rid of the natural log, we are able to do this integral. So let's simplify everything. This is x squared plus 2x ln x minus the integral. This is just x plus 2 inside the integral. And the next step, we'll evaluate that integral. The integral evaluates to minus a half x squared minus 2x plus our constant. So now this is what's going to go into this spot where we originally had the integral. So we've got x squared plus x ln x squared minus all that stuff, x squared plus 2x ln x minus a half x squared minus 2x plus c, and then we'll just distribute the minus sign. So this is x squared plus x ln x squared minus x squared plus 2x ln x plus a half x squared plus 2x, then minus of a constant is still just constant, so plus c. And that is the solution to the original integral up there. In the future, we'll learn how to apply integration by parts, in some cases even when it doesn't seem to simplify the integral at all.